So welcome back. Question number 13. We have found the differential equation whose solution is given by y is equals to e raised to the power of minus x, parentheses open, a cos x plus b sin x, where a and b are arbitrary constants. Good. So to solve this problem, we will need a little bit of skills in differentiation and then a little understanding of some techniques that we apply when we have solution. Try to solve equation using, we have y is equals to e raised to the minus x, parentheses open, a cos x plus b sin x. Now there are multiple ways to go. One of the ways we can solve this problem is to differentiate this equation twice, but we could multiply e raised to the minus x by each of the expression in there, and then before differentiating, or we could leave the expression like this and just apply the product rule. So remember, this is a function of x, this is also a function of x, as you can clearly see on the board. So you leave this entire thing like this and then use product rule, or you multiply e raised to the minus x by each of these things and use product rule on the two terms. That's going to be the very same thing. So I'm just going to leave it like this. So the derivative of y is y prime is equals to, I'm going to use product rule. So I'm going to differentiate e to the minus x and then keep this entire thing constant. So the derivative of e to the minus x is minus e raised to the minus x. And then I keep a cos x plus b sin x constant. Then I say plus, I hold e raised to the minus x, and then differentiate a cos x plus b sin x. So the derivative of cos x is negative sin x. So negative sin x times a is negative a sin x, plus the derivative of sin x is cos x. Cos x times b is b cos x. That means the derivative of the entire expression here is this plus this, using the product rule. Now we are not done. Remember, we are not done. We have to find the second derivative and then observe a pattern. So if we differentiate y prime, we have y prime prime equal to, so for here we have to use product rule because we have two functions of the independent variable x, and then here we also have to use product rule. So let's use product rule here. We differentiate minus e to the minus x. The derivative of negative x is negative 1, so that negative 1 we multiply this negative to get it positive. So the derivative of this is e to the minus x. Then we hold a cos x plus b sin x constant. The first thing. And then the next one, we hold this constant, minus e to the minus x, and then we differentiate y in here. What will be the derivative of a cos x plus b sin x? We already know that, and this is it. So the derivative of this, differentiate sin x are minus, if I differentiate cos x, so it's minus a sin x, plus differentiate sin x, that's b cos x. So the derivative of y in here is this. So for the derivative of this, using product rule, we have this entire thing. And then we have to differentiate this. So we differentiate this, we have minus e raised to the minus x, and then we hold this constant, minus a sin x plus b cos x. So we differentiate this and hold this constant, plus we hold this constant, e to the minus x, we hold it constant, and then we differentiate y in here. So what will be the derivative of minus a sin x? Differentiate sin x, that's cos x. So this entire thing here is going to become minus a cos x. What will be the derivative of cos x? That's negative sin x. So the derivative of b cos x is negative b sin of x. Simple as it is. As simple as it is. Great. So we should have actually written this here, but because it doesn't fit, so write it here. So we're going to rewrite y prime prime and try to simplify the entire thing here. So what we observe is that here we have minus e to the x, a sin x plus b cos x, minus e to the x, a sin x plus b cos x. So these and these are the same with the same sign negative. So we rewrite this, e to the minus x, parenthesis open, a cos x plus b sine x. And then this and this we add because they are the same expression with negative. So it's going to be minus 2 e to the minus x, parenthesis opening, minus a sine x plus b cos x. Great. And then for the last expression under here, we have a negative, negative. We find out a negative. We have minus. So this negative is going to affect e to the minus x. So it's going to be minus e to the minus x, parenthesis opening. This is going to be positive now. A cos x plus b sine x. If we do that, so that's what if we actually going to have factor out a negative from here. This negative is going to affect this, so it's going to be negative. Now let's see something. We have e to the minus x, a cos x plus b sine x. E to the minus x, a cos x plus b sine x. This and this are the same with different sign. So what happens? They automatically cancel out. This and this are going to cancel out. So I'm going to have y prime prime is equals to only this minus 2 e to the minus x, parenthesis will be minus a sine x plus b cos x. Y prime prime is going to be equal to this. Now, once we have this, we can move on to the derivative of y prime. So what was the derivative of y prime? We had, I'm going to write that in red. We have y prime is equals to minus e to the minus x. So it's minus, I'm just going to write minus 1 onto, I'm going to use a bracket, e to the minus x parenthesis will be a cos x plus b sine x, a cos x plus b sine x, and then plus e to the minus x onto minus a sine x plus b cos x. Now this is how we're going to have. Just consider that. Now, from this first derivative we found, the entire expression e to the minus x, a cos x plus b sine x, the entire thing from here is y. So y is e to the minus x, a cos x plus b sine x. So the entire thing replaces with y. So we have y prime is equal to minus 1 times y, so it's minus y plus e to the minus x times minus a sine x plus b cos x. Great. So we wrote y prime in terms of y because something in y prime resembles a y, so we just replace that and that's it. Now, once we do that, we have this equation now where we want to try to get rid of this negative a sine x plus b cos x, because remember this entire thing is the very same thing here, right? So we can make this is subject by sending this across. So we send this across, we have, I'm going to use red, we have y prime plus y is equals to e to the minus x parenthesis will be minus a sine x plus b cos x. So you have y prime plus y is equal to this. Great. But what do we have here? We have e to the minus x parenthesis will be a sine x plus b cos x. E to the minus x parenthesis will be a sine x plus b cos x. So this entire thing, we're going to replace it. I'm going to replace the entire thing with y prime plus y. So we have y prime prime minus 2 parenthesis will be, this entire thing is y prime plus y. And we have this equal to minus 2. So y prime prime equals minus 2 multiplied by this entire expression, which we say is y prime prime plus y. So we can just move on and do the multiplication. So we have y prime prime is equals to, this time this is minus 2 y prime, this time this is minus 2y. And then to put this equation in a general form, we can send all of these across. So we have y prime prime plus 2y prime plus 2y equal to 0. So, ladies and gentlemen, this is a differential equation whose solution is y is equal to e to the minus x, parenthesis open, a cos x plus b sin x. This is that differential equation. So you see what we did, we send this across, all of them become positive, and then we have that. So thank you very much for watching, and see you in our next video.